Hello, NEET aspirants. Today, we are delving into a problem extracted from NEET 2023 question paper. Imagine a lengthy wire conducting electricity. Now, configure that wire into semicircle stretching from point A to point B as depicted in figure. Our objective is to determine the magnetic field at a designated point denoted as P with the assumption that the current remains steady. Before embarking on the solution to this intricate problem, let us take a moment to revisit fundamental formula. Are you ready to approach this problem? Let's commence. Imagine you have a short conductor AB carrying current I as indicated by the animated red arrow. Around this conductor, there is a magnetic field represented by animated yellow arrow. Now, to figure out the direction of this magnetic field, we can use the right-hand thumb rule. Here is how it goes. If you pretend to hold the conductor in your right-hand palm with your stretched thumb pointing in the direction of current, in our case, the animated red arrow, your curled fingers shows the direction of magnetic field. In this scenario, at point P, the magnetic field is pointing into page, which we represent with a circle and a cross. Now, let's introduce a perpendicular distance r from point P to the current carrying conductor. If you draw a line from point B to point P, it forms an angle beta with the perpendicular PO. Similarly, if we draw a line from point A to point P, it forms an angle alpha with the perpendicular PO. The formula for the magnetic field at point P is given by B is equal to mu0 I upon 4 pi r into bracket sin alpha plus sin beta bracket close, and the direction of the magnetic field is pointing into page. Now, let's shift point P to the right directly above point B. In this new position, the angle beta becomes 0 and angle alpha starts increasing. If we extend the length of the current carrying conductor to our left infinitely, angle alpha eventually becomes 90 degrees. So, by substituting alpha is equal to 90 degrees and beta is equal to 0 degrees in our formula, we get the equation B is equal to mu0 I upon 4 pi r into bracket sin 90 plus sin 0 bracket close. Since sin 90 is equal to 1 and sin 0 is equal to 0, we get B is equal to mu0 I upon 4 pi r. Now, we can use this simplified formula to find the magnetic field at point P due to two semi-infinitely long wires. As shown in diagram, points A, B and P are all in a straight line. This alignment allows us to use the magnetic field formula we derived earlier. Point A and point B are at same distance of r from point P and same current is flowing through long current carrying conductor. Therefore, both have same magnitude of magnetic field. Since the direction of magnetic field produced by both the conductor is in the same direction and pointed into the page, which can be found out using a right-hand thumb rule. Therefore, we can algebraically add them up. Upon adding them, we obtain the magnetic field at point P due to the long conductors as B is equal to mu0 I upon 4 pi into r plus mu0 I upon 4 pi r. On simplification, we get B1 is equal to minus mu0 I upon 2 pi r. Negative sign indicates magnetic field is pointed into page. Now, magnetic field at the center of a circular loop is given by mu0 Ni upon 2r. Here, n is number of turns. Since we have semicircle, we can substitute n is equal to half. Then we get magnetic field as B is equal to mu0 I upon 4r. Positive sign indicates magnetic field is pointed away from the page. To find the direction of magnetic field due to circular loop, we can use right hand curl finger rule, which states curl your right hand fingers along the direction of a current, then stretched thumb shows the direction of magnetic field. In our case, it is pointed away from the page. So, B is equal to plus mu0 I upon 4r. We have two contributions to the magnetic field at point P. The first contribution B1 is due to the infinitely long conductors, and the second contribution B2 is due to semicircular single turn loop. When we add this contribution together, B1 plus B2, we get D is equal to minus mu0 I upon 2 pi r plus mu0 I upon 4r. As 2 pi is equal to 6.28, so the denominator of mu0 I upon 2 pi r is greater than the denominator of mu0 I upon 4r. Greater the value of denominator, smaller the value. Thus, value of mu0 I upon 4r is greater than mu0 I upon 2 pi r. Therefore, direction of resultant magnetic field will be the direction due to semicircle, that is pointed away from page. Now, we will simplify further. By taking mu0 I upon 4r common, we get B is equal to mu0 I upon 4r into bracket 1 minus 2 upon pi bracket close. Therefore, option B, which states that the direction of the resultant magnetic field is coming out or away, is correct. As we wrap up this video, we kindly ask for your support. If you found this content valuable, please take a moment to like, comment, and share it with others. Don't forget to subscribe to our channel for more insightful content. For additional resources and in-depth learning, visit our website www.genet.com. There, you will find the concise notes and wealth of practice MCQs designed to enhance your NEET preparation. The best part? Our website is completely free, with no registration required. Thank you for being a part of our learning community. We look forward to see you in the next video. Until then, stay tuned, stay focused, and enjoy your journey of happy learning.